This is video 9.1, D is in Delta, and this is trigonometry, and we are in example 8. There's the formula for compound interest there. Becky Anderson must pay a lump sum of $6,000 in 5 years. So she needs to pay $6,000 in 5 years. What amount deposited today at 3.1% compounded annually will grow to $6,000 in 5 years? All right, so let's look and see what we've got. What amount deposited today? That would be the principal. That's what we're looking for. And let's see if we can fill in all the other blanks. Okay, so what are we trying to do? We're trying to have $6,000 in 5 years. So A is $6,000. That's what we're trying to get. Our interest in the amount we invest add up to be $6,000. Our interest rate is always easy. It's the one with the percentage sign. Move that over and it becomes 0.031. That's the number we're going to work with. 5 years is going to be our time. And the only other thing we're looking at is M, compounded annually. So how many times per year? Annually, one time, every year. So there's my letters. So I've got $6,000 equals my principal, which is what I'm looking for, 1 plus my rate over 1 to the 5 times 1. Alright, so we've got 6,000 equals P times 1.031. So we're just adding those to the 5th power. Okay, so far so good. I'm going to take this whole thing and move it under here to isolate my P. Now I'm going to take 1.031 to the 5th power, and then I'm going to take 6 and divide it by that, and I end up with a P value of $5,150.60. So she wants $6,000 at the end of 5 years. She's going to have to invest this amount of money, put it in the bank, and get this interest rate so that at the end of 5 years she'll have her $6,000. Alright, if, letter B says if only $5,000 is available to deposit now, what annual interest rate is necessary for the money to increase to $6,000? Okay, so let's say she doesn't have this much money to put in the bank. Let's say she only has $5,000, but she still wants $6,000. Is this interest rate going to have to change? Yeah, it's going to have to be a higher interest rate because she doesn't have as much to invest. So let's do the same thing, only we're going to have as our P $5,000. We know what our P is. We know what we're going to have to invest, but what we're looking for is our R. We don't know what our R is, but we know this is 5, we know that's 1, and we know we're going to have $6,000 here. So what we're looking for is that right there. So 6,000 equals 5,000 times 1 plus R to the 5th power. Okay. So here's what I'm going to do next. I am going to take this and move it over here so that I can isolate this. So I'm going to divide that by 5,000. Get rid of that. So I have 6 over 5 equals 1 plus R to the 5th power. Alright, how do I get rid of an exponent? I take that root of both sides. And now I have 1 plus R equals the 5th root of that. Or instead of writing it as the 5th root, I probably am going to be better writing it to the 1/5 power. Okay, so I'll write it that way. Subtract 1 from both sides. Let's put that up there. R equals 6/5 to the 1/5 power minus 1. Okay, so this is where I get my calculator, and I end up using the key that looks like this. I think it looks like this. Maybe the X and Y are flipped around. But that allows you to put a 5 in here for your index and 6 divided by 5 here, and that will give you the fifth root of 6/5. Then subtract 1 from it, and you get 0.0371, or 3.71% is the interest rate you have to have, because you only have $5,000 and you want $6,000 at the end of 5 years. So you have to have a 3.71% interest rate. And that's it for example number 8. Okay, so that's as far as we're going to go in 9.1, although now that I'm looking at the problems that we're doing here, I do want to go on just real briefly on E. The letter E, there is an explanation on what the E is, but E is kind of like pi. It's a number that's 2.718281828, and it goes on forever, just like pi does. So your calculator should have a button that looks like this. And anyway, we'll go ahead and just look at example 9 here. They give us what is called continuous compounding, which means instead of having a number of times, like our M was in the previous examples, how many times are we compounding? It's compounded every second of every day. So if it says compounding continuously or continuous compounding, we're going to go ahead and use this formula here, which is in the middle of page 396. So it says, suppose $5,000 is deposited into an account, this is example 9, paying 3% interest. So P is our amount deposited, our principal. Our interest rate is 3%, or 0.03, compounded continuously for 5 years. Find the total amount on deposit at the end of the 5 years. So we're looking for A. So A equals $5,000. E, okay, we're just going to leave the E alone, to the R power 0.03 times how many years? 5. So A equals 5,000 E to the 1.5, and your calculator, again, if it has this button, that means you can put 1.5 in there for the X, and it will give you a number, and it should give you 1.161834 for your E value. And then we're going to multiply that by 5,000, and we get 5809.17. So that is the amount of money you will make for your money that's compounded continuously over 5 years. So that just gives you an idea of what that E does. You just put the E, you find that E to the X button that we have right here, and that should take care of business for you. So that's it for lesson 9.1 in trig.